Say wonderful day, Sai folks! I am back for another episode of exploration, discovery, and fun. How have you been? I hope you are all fine and doing great. I know that you are all excited for today's learning session, so get ready with your pen, your paper, and your modules. Fasten your seatbelt as we take off to the world of science. Let's go! I know many of you love dancing and singing. I see lots of videos over the internet with too many likes and shares. That means you nailed it. Have you ever wondered how we could sync our dance steps and lip movements whenever we do videos like this? That is because we clearly hear the sounds from our phones or other devices. Yes, it is because of the sounds that you hear. Without sounds, you won't be able to come up with that perfect video for your social media accounts. So, it is very important that the sounds we hear should be clear and audible to us as we record. Otherwise, it would be a total flop. Now, I have a question. What are sounds?
Sounds are anything that we hear from our surroundings, like sounds of birds, sounds of vehicles, and more.
For me, it is the things that we can hear. Maybe it came from our voice, the instruments, and anything that we can hear.
For me, sound is anything that is pleasant to our ear. And if it's not pleasant, I think that's already a noise.
Sound is anything that can be heard, just like this one.
You guys are correct. Sounds travel in the form of sound waves, and the vibrations are heard when they reach our ears. But why are there sounds that could hardly be heard or delayed? Do you have any idea? No response? Well, that is because there are factors that affect the speed of sound. You'll get to know more about these in our lesson today. At the end of our lesson, you were expected to have investigated the effect of temperature to the speed of sound. Sound waves are affected by many factors as they travel in various channels and media. These media where sound waves travel can either be solids, liquids, or gases. Where do you think sound waves travel fastest? That's right. They travel fastest in solids and slowest in gases. Elasticity is the ability of a deformed material to return to its original form, shape, or size after removing the force that causes the deformation. Some examples of elastic materials are steel and rubber. Atoms and molecules in elastic materials have a strong attraction towards each other, and as a result, sound energy is transferred faster. Meanwhile, density is the intrinsic property of any object. It is an object's mass per unit volume, which is obtained by dividing the mass of the object by its volume. It is a description of how compact the atoms and molecules in an object are. In less dense objects, the atoms and molecules are less compact, meaning the transfer of sound energy is slower. On the other hand, in denser objects, the atoms and molecules are more compact. Thus, sound energy is transferred faster. Aside from the properties of the medium where sound waves travel, there are other factors that also affect the speed of sound, one of which is temperature. We said earlier that sound waves travel in different media. One of these media is gas. Have you ever wondered or noticed that there are times when sounds are quite delayed, especially when heard from afar? That is because the temperature of air has something to do with it. The speed of sound in dry air, which is at 0 degrees Celsius, is around 331 meters per second. That speed increases by 0.60 meters per second with every increase of 1 degree Celsius, because as temperature rises, molecules in the air move faster and make contact with each other more often, resulting to transfer of sound energy. The warmer the temperature, the faster sound travels. Is it clear now? All right. For you to better understand this, let's have an experiment. For this experiment, we need the following materials: 3 graduated cylinders, tuning fork, rubber mallet, thermometer, hot water, cold water, and water at room temperature. Now that we are ready with our materials, let's start. The first thing we have to do is to label the 3 graduated cylinders with room temp, hot, and cold respectively. For this experiment, we pour 50 milliliters of water at room temperature in the graduated cylinder. After that, we have to sound the tuning fork by striking it to the rubber mallet. Then we hold it on top of the graduated cylinder. Did you hear any sound? Yes, there was a sound. If it happens that there is no sound produced, you have to increase or decrease the amount of water poured in the graduated cylinder until we hear the desired sound. Next, let us fill the 2 remaining graduated cylinders with hot and cold water respectively. We have to take note of the temperature in each of the graduated cylinders before we sound the fork. The room temperature water is at 30 degrees Celsius, the hot water at 85 degrees Celsius, and the cold water at 7 degrees Celsius. Now, let's sound the tuning fork and place it on top of each cylinder. Take note of your observations. Now that we are done, it's time to answer my questions. Which cylinder produced the loudest sound? Awesome! It is the cylinder with hot water. Which cylinder produced the highest pitch sound? Right! It is again the cylinder with hot water. If pitch is directly dependent on frequency, which cylinder produced the highest frequency sound? Very good! It is still the cylinder with hot water. Since wave speed is directly dependent on frequency, which cylinder produced the fastest sound? Again, it is the cylinder with hot water. For the last question, how would we relate the temperature of the medium with the speed of sound? The higher the temperature of the medium, the faster the speed of sound. Now, you have known that temperature of the medium where the sound travels really affects its speed. And this can be expressed in the equation V is equal to 331 meters per second plus 0.6 meters per second over degrees Celsius times T, where V stands for the speed and T for the temperature in degrees Celsius. To be able to understand solving this, let's have these examples. What is the speed of sound in the air if the temperature is 30 degrees Celsius? First, let's write the given. The temperature is 30 degrees Celsius. After that, let's have the solution. We first write V equals 331 meters per second plus 0.6 meters per second over degrees Celsius times T. Now we substitute the value of T, which is 30 degrees Celsius. Then we simplify by omitting the units for temperature, degrees Celsius. After doing that, multiply 30 and 0.6. And that will give us 18. We then add that to 331. And finally, we come up with 349 meters per second. Thus, the speed of sound in air at 30 degrees Celsius is approximately 349 meters per second. Did you understand? Why don't we try once more? This time, you have to solve a problem independently. I'll give you 30 seconds to do it. Are you ready? What is the speed of sound in the air if the temperature is 17 degrees Celsius? Your time starts now. Time's up. I hope you got the correct answer. Can you show me your answer? The correct answer is 341.2 meters per second. You guys are really awesome. Do you miss going in a concert with your friends? Me too. I know many of us love watching concerts, especially when favorite performers are there. Have you noticed that most concerts are held during nighttime? Why do you think so? There are many reasons why concerts are usually held at night. One of these is because daytime and nighttime temperatures have effect on sound. Why? You'll find out as we talk about the properties of sound: reflection and refraction. Just like any other waves, sound also exhibits reflection. Reflection is usually described as the turning back of the wave as it hits a barrier. The echo is an example of a reflected sound. Reverberation, on the other hand, refers to multiple reflections or echoes in a certain place. This best fits the bathroom, which enhances the voice. In closed concert venues, reflection of sound and reverberations are noticeable. This happens because the sound waves hit the walls of the closed space and remain hitting barriers that causes sound echoes. Sound waves involves a change in the direction of waves as they pass from one medium to another. Sound waves travel slower in cooler air than in warmer air. When a sound wave propagates in the air with temperature which changes in altitude, refraction happens. A sound wave travels from air of higher temperature to lower temperature. During the daytime, sound travels faster at the Earth's surface since the air molecules are hotter due to the energy absorbed from the Earth's ground. The air molecules at the higher altitude are cooler than those at the Earth's surface, causing sound waves to refract upward. On the other hand, during nighttime, the Earth's surface is cooler and the layer of air immediately above it is also cooler. As a result, sound travels faster at the higher altitude and is refracted or bent towards the ground. To answer why concerts, especially those outdoor concerts, are held mostly during nighttime is that the temperature of the air during nighttime is warmer, which means that the sound refracts towards the ground. That is all for today's discussion. I hope that you learned a lot from that. To test how much you learned, let's do the quiz. Which of the following factors does the speed of sound depend? A. Density. B. Elasticity. C. Temperature. Or D. All of the above. An echo occurs when a sound wave is A. Absorbed. B. Reflected. C. Refracted. Or D. Transmitted. What happens to the speed of sound as the temperature increases? A. Constant. B. Decreases. C. Increases. Or D. Cannot be determined. Which phenomenon explains why sound is heard at longer distances at night than in day? A. Echolocation. B. Reflection. C. Refraction. Or D. Reverberation. How fast does sound travel if the air temperature is 20 degrees Celsius? A. 334 meters per second. B. 340 meters per second. C. 343 meters per second. Or D. 345 meters per second. Did you get all correct answers? That's awesome! I hope that you are having fun and learning so much from our learning sessions. This is your teacher MJ. See you again in our next episode as we explore, discover, and enjoy life. This is DepEd TV.